Particle representations are useful for helping to visualize how intermolecular interactions can establish macroscopic properties. So for example, boiling point, melting point, electronegativity, vapor pressure, and so on. So here is an example of H2O in a liquid phase. And we should pay attention to the difference in atomic radii of the molecules. So remember that the atomic radius decreases as we move from left to right in the periodic table and increases as we move down. So you can see that the oxygen atoms have a larger atomic radius than the hydrogen atoms, and the dipoles are oriented such that the negative dipoles around the oxygen face the positive dipoles around the hydrogen. And here we have a special type of dipole-dipole interaction between the molecules called hydrogen bonding. Now in this example, we have sodium chloride dissolved in water. So because the sodium atom loses an electron, it loses a shell, and therefore has a smaller atomic radius than the oxygen atoms. Whereas the chlorine atom has a larger atomic radius than the oxygen atoms. And here we can see the negative dipoles around oxygen face the sodium cation, whereas the positive dipoles around hydrogen face the chlorine anion. So here we have ion-dipole interactions. And in this third example, we have hydrogen gas. So we have diatomic molecules that are non-polar, and the attractions between these molecules are London dispersion forces, because you can have temporary fluctuating dipoles. And here we have sodium chloride in the solid phase. So the sodium and chlorine ions are packed together to minimize repulsion. So here we have strong ionic bonds between these ions.